Understanding polls, the significance of a 95% confidence interval and a 3% margin of error. Whenever we see poll results, whether it's in support or opposition to a certain issue or candidate, the results are often accompanied by a phrase that goes like this: with a 95% confidence level and a 3% margin of error. Why is that? In reality, anyone, not just statistical experts, can conduct a poll. All it takes is randomly selecting a representative sample of 1,000 people and surveying them on a particular issue or candidate to obtain the confidence and margin of error as mentioned above. For instance, if the poll results show that 530 people support, or are in favor of, a particular person or legislation, you can state that, with a 95% confidence level, 53% equals 530/1000 of the population supports this person or legislation, with a margin of error of plus or minus 3%. This means that, based on this sample, there is a 95% probability that the actual support lies between 50% and 56%, where 50 equals 53 minus 3, and 56 equals 53 plus 3. You might wonder where the 95% confidence level comes from and what exactly is meant by a margin of error of plus or minus 3%. Simply put, it's as if we're flipping a coin 1,000 times, conducting 1,000 Bernoulli trials, and the result is heads 530 times. This implies that there is a 0.53 probability of getting heads, which is the sample mean. Using the binomial distribution formula, we calculate the standard deviation of the sample mean, which is the square root of p times 1 minus p divided by n, or in other words, 0.53 times 1 minus 0.53 divided by 1,000, and then taking the square root, which gives us 0.0158 equals 1.58%. Therefore, we have a sample mean of 0.53 and a standard deviation of the sample mean of 0.0158. If the total voting population is large enough, we can assume that the actual voting results will follow a normal distribution. According to the bell curve of normal distribution, 95% of the values will fall within 1.96 standard deviations of the mean, central limit theorem. From the example above, the sample mean is 0.53, and 1.96 standard deviations amount to approximately 3.1%, or roughly 3%. In fact, with a random sample of 1,000 people and p not being an extreme value, the 1.96 standard deviations of a binomial distribution always hover around 3%. In other words, a 95% confidence level and a 3% margin of error occur naturally. The real accuracy of a poll, however, lies in whether the sample is truly random. Randomly picked telephone numbers may not necessarily provide a random sample. Stopping random people on the street may not be random enough. Online polls are also not random. Truly random sampling is a complex subject.